This is a review for a compound interest calculation. So we'll start off here. You have an initial principal called P sub 0, P naught. You have an interest rate R, and the interest rate is per year. And you have a compounded n times per year. And we're going to have this P of t function is the amount at time t, where t is in years. All right, so the way that this works is you have a bank account, you put in an initial principal P naught, and so we're going to say P of 0 years is going to equal P naught. It's how much is in there initially. All right, so let's say n is equal to 1 times per year. Right, you compound 1 time each year, so the end of the year. What that's going to mean is you're going to have, okay, well at the end, so you have P of 1 year. At the end of that year, you're going to have the initial amount you started with, and then you're going to have a little bit more from the interest rate on the money you had in there. And so in our case, let me also specify R. So let's say R is 5%. And again, that's per year. Everything's in per years. Per year. All right. So 5%, well, I have to convert that. So 5% is 0.05. And I'm going to have 5% more of what I started with. So that's going to be P naught times 0.05, 5%. And so at the end of the year, I have what I started with and a little bit more. And in order to make that a little cleaner, we're going to factor out the P naught. So we get P naught, and we get 1 plus 0.05. Right? We're not going to clean that up anymore because the compounding changes if we actually start increasing the compounding. So then you can get a little more money if you actually compound more often. So what that's going to mean is, again, well, let's say P of 0 is equal to P naught. We're going to have an interest rate again of R equals 5% per year. And then we're going to have N is equal to 12, meaning we're compounding monthly. All right. And now from here, what's the formula going to be? Well, so this would be a really good deal if it actually had 5% at the end of every month, but that's not how it ends up working. So the way that these are defined is we'll have P naught, and then we're going to have at the end of the first month, so I'll say P of 1/12. So that's the end of the first month, right? Because this is in years. That's going to equal P naught times, I'm going to have the initial amount I started with plus, now it won't be 0.05% because that would be pretty awesome if you got 5% at the end of each month. Instead, they kind of split that 5% into each compounding for the year. So instead, it's going to be 5% over 12. Right? So that's the end of the first month. If you go to the second month, so I'm going to do P of 2 over 12. Well, you're going to start out with what you had at the end of the first month. So that would be P of 1 over 12. And that's going to be multiplying the interest rate, the amount you'll have at the end of the month. This thing, you'll have what you started with at the beginning of the month, and then you'll have a little bit of interest tacked on. So you're going to have 1 plus 0.05 over 12. And if you simplify that, P of 1/12, well, that has P naught, but then I have the 1 plus 0.05 over 12, and I also have the 1 plus 0.05 over 12 here. So if I do that, I end up with it squared. So 1 plus 0.05 over 12 squared. And so this was for 1/12 of a year, so at the end of 1 month. This for 2/12 of the year, at the end of 2 months. I'm going to put here, there's a 1, there's a 2. If I do P of 3 over 12, right, that's going to be P of 2 over 12, what I started with at the beginning of the end of the second month, beginning of the third, and then times again the amount of interest I'm going to get on that new amount that got compounded every month. So 1 plus 0.05 over 12. So then that's going to equal, this has P naught in it again. Then it has a square root of this, and I multiply it again. So it ends up being 1 plus 0.05 to the 12th, and then cubed. All right, so if you continue that down, you'll end up with p of 12 twelfths, right? So we did this 12 times, so that's p of 1 year. It's going to equal p naught times 12 compoundings, one for each month. So 1 plus 0.05 over 12 to the 12th. All right, so that's compounded monthly. Well, now what if we want to write the formula in general? So let me just draw that line. So what if I just have, p of 0 equals p naught, and I have a rate r, and I have an n, and that's it. All right, so then the formula for that, if I want to find p of 1, in this case after 1 year, it's going to equal the initial amount I had, and it's going to be n compoundings. It's compounded n times. So 1 plus, we're going to have n compoundings, and then it's going to be the interest rate r, and it has to be in a fraction, over the number of compoundings. And so here you go. So then if you want to do this daily, so meaning, n was equal to 365 days, so you get, p over 1 over 365, p over 2, p equals p of 2 over 365, p of 3 over 65, dot, 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 p of 365 over 365. It would end up being p naught of 1 plus r over 365 to the 365th power. All right, so that's how this compounding formula works. And now we're going to see how mathematicians played with it to get something interesting to happen.